So in this video, I'm going to be talking about ancient astronomy in India and China. I was hoping to get to more cultures, but I'm already making these videos longer than I want to make them, and so there's just kind of not time to fit this all into this week. So we're going to have to stick with Mesopotamia, India, and China. If you haven't watched the video on Mesopotamia yet, I'd recommend that you start with that one, because I say some stuff at the beginning about what I mean by ancient astronomy that's going to be relevant here too. Okay, so let's dive into ancient India. So when we're talking about ancient India, the most important collection of texts that there is in this time is the Vedas. So the Vedas are this quite large collection of scriptures. They're kind of religious, philosophical, ethical, but also cosmological. So they're a really comprehensive set of texts giving people a kind of worldview. They're setting out the big picture of what the world is kind of like, and they hold this incredibly important place even to this day within Hinduism. So these things are composed over a period of seemingly centuries. It's not super clear when they were written. And in fact, in the beginning, they weren't written exactly. I'll come back to that. But it looks like 1500 BCE is the earliest dates that they might have been composed. So within the Vedas, we find a whole bunch of rituals. And these rituals are specifically tied to things like the summer solstice, the winter solstice, the equinoxes, and full moons, things like that. So the timing of the rituals is tightly correlated with astronomical events, which means people have to pay close attention to what's going on in the sky to perform these rituals properly. Now, the timing of this was not incidental to the composers of the Vedas. The timing of these things is one of the timing of rituals is one of the ways that you get sort of the human realm aligned with the larger cosmic realm. And one of the kind of core themes of the Vedas is the reflection of our lives in the cosmos. So our human lives are in some sense mirror images of the larger cosmic process. So doing these rituals in accordance with astronomical events isn't incidental. It's actually kind of core to their meaning for people. Things like the shape of the altars also have kind of cosmological significance. Though, now, because they're using both solar and lunar events to time these rituals, that means they have to have a combined solar-lunar calendar. And that's pretty tricky to get working properly. So because the solar year is something like 365-ish days, and the lunar month is 29 to 30 days, something in there, those numbers don't divide evenly into each other very nicely. So composing a combined solar-lunar calendar is a bit of a mathematical trick. Now, they used a system that was quite similar to the one that we talked about in the video about Mesopotamia. So they start with a 360-day solar year, 30-day lunar months, and then kind of adjust as necessary. There's some speculation that there was a transmission of this idea between these two cultures. It's not super clear whether there was such a transmission, or if there was, which direction it went in. But it's an interesting coincidence at minimum. Now, so they have to do something similar to the Mesopotamians, which is to add in an intercalary month. That is, every once in a while they stick in an extra month into the calendar to make sure that the solar and lunar cycles line up properly. In the later Vedic writings, we see what's called the 27 Lunar Mansions. So this is a division of the night sky into 27 kind of equally sized sections, 27 or sometimes 28. Now, each one of these lunar mansions has a kind of significance, so religious or sort of symbolic significance, and the position of the full moon in some part of the sky was regarded as the kind of a significant moment that needed to be reflected in the kind of rituals that you would do. This remains, I think, the basis for Indian astrology to this day, although I don't know much about that bit. Okay. So something interesting that I'd like to point out about the Vedic tradition is their information technology. I'm going to keep coming back to IT over and over again in this course because I think it's a fascinating requirement for the possibility of science. For centuries after they were composed, the Vedas were transmitted only orally. So there was no written record. And these things are long. I showed you at the beginning. They're like book length, sort of like bits of knowledge. And they had to be memorized and orally transmitted from one person to another. And it looks like they were transmitted with very high fidelity, so very low error rate for centuries. For centuries, it was just one person telling another. I don't know about you, I can barely get a story through one friend to another before it's transformed. And so to be able to transmit these texts over centuries with very little errors introduced is an amazing feat. So they didn't do this casually. This was done with enormous effort and very specific training techniques. So one of the things that they would do, for example, was the Vedas were chanted. They were chanted with a series of tones. I won't try to imitate it, but you can go on YouTube if you want to listen to this. So Rig Veda chanting will get you on YouTube a version of this. So there's a kind of rhythm and musical quality, and that enhances memory. There's also, so they'd have them chant it with this kind of, it's not like a song exactly, but different tones and a kind of steady rhythm. Then, once you're able to do that, you also have to chant it one word at a time. So they get them to chant it in a different way. So using a different way of accessing the same text. So you've got this flowing rhythmic version. You've got this halting one word at a time version. Then they would also get you to say, chant it with saying one word and the next word. So you would do like little combinations of two words. There was a bunch of these techniques. So in order to make sure that it's transmitted orally with very high accuracy over centuries, they would have you repeat it over and over again in a bunch of different ways so that it's stored in your brain in a bunch of different formats, and you can kind of cross-check these formats against each other. So if you introduce an error into one way of saying it, you've got 4 other ways of saying it that you can use to error correct that one. So I think this is just an amazingly powerful set of techniques and amazingly like labor intensive. This is hard work to get these things to be transmitted accurately over centuries and centuries. Okay, so we're talking about calendrics, a post-Vedas composition. So this seems to have been a bit later than the Vedas, but they start to get into mathematical calendrics. So as I've been emphasizing, the calendar is of profound practical significance, but also spiritual significance to this culture. And they start doing some pretty careful math on it. So I do apologize for how I'm going to butcher the pronunciation of this. The Vedanga Jyotisha gives a very early mathematical treatment of calendrics. No one's quite sure when it was composed, but something like 1400 BCE to 400 BCE. And they come up with some rules. So as I mentioned before, the intercalary month is a kind of technique for making the lunar and solar calendars match up and having them both match up with actually what's going on in the world. We see in this text an attempt to kind of formalize that process. So they use a kind of 5-year cycle, and in that 5-year cycle, you get a solar year adding up to something like 366 days, which is pretty close. And the number of, so synodic months are the months of the moon, and sidereal months are a division of the solar cycle into months. And you can see they get them to be pretty close to each other. So if you use the schema developed in this book, you can get the solar cycles and the lunar cycles to almost match. And they give you, this book gives kind of formal rules for doing this, whereas before it seemed like people were just kind of adding them in as necessary. So you just watch what's happening, and when things go out of sync, you add in a month. Now people start trying to generate rules for when it's going to be appropriate to add in that month. Okay, so just another thing I'd like to mention about the Vedas. This is less to do with astronomy, but it does have to do with people's conception of the universe, and particularly their conception of time. So the Vedas have this very complex system of units of time. And I've represented just a very small part of it here, but they've got units of time that go down to 25 microseconds, 25 millionths of a second to tenth of a second to roughly a second to hours. And then, of course, in the days and the months and seasons and years. And then the upper end, they've got units of time that are unimaginably vast, like the Kali Yuga is something like 432,000 years. The Kalpa is something like 4.32 billion years. And the Mahakalpa is something like 311 trillion years. I think this is just an astonishing accomplishment of imagination for this time. So if you ask an ancient Greek, how long is the biggest unit of time you can think of, they're not going to come up with numbers anything like this. So the Vedic culture had this profound interest in time, the cycles of time, and had the imagination to think of to come up with a word for 311 trillion years. And that's just one, that's not even the expanse of time in their opinion. So in the Vedic picture of the universe, time is cyclical. So when you get to the end, you start back at the beginning. So these units of time are just being used to describe a cycle that goes over and over and over again. It's really an astonishingly massive imagination of how big and how long time could be. And as you saw before, they're willing to slice this down to unbelievably fine units of time. So I think it's mind-blowing. I think it's fascinating that they were picturing time in ways that wouldn't become practically useful to humans for thousands of years. And the tools that they had to measure time in this period were inexact at best, but nonetheless, they were interested in actually measuring time. So making sure that the rituals were performed sort of regularly, that the calendar matched up with nature. All of this required some way to actually measure time. So this is one that's mentioned in that text I just talked about, the Vedanga Jyotisha, and it seems to show up in various places throughout the ancient world, but we know with pretty high confidence that it was used in ancient India. And this is the Clepsydra, or a water clock. Let's call it a water clock. And it works by, basically, you fill up this vessel, it's got maybe a little hole in the bottom, and you know how long it takes the water to pass through the little hole. So you can use the outflow of water to measure the passage of time. This isn't as good as your watch, but it is a pretty creative and pretty low-tech way of measuring time. So they were actually concerned with and did real work on connecting up this sort of complex, spiritually relevant notion of time with actual measurements of the natural world. Okay, so really brief skim over ancient Indian astronomy. To be honest, my favorite period of astronomy in India is the classical era, which we haven't quite got to yet. So I really I'm going to really try hard to come back to the classical era of astronomy in India, where you get some really cutting edge work that in some sense blows everybody else's work at the time out of the water. So India is the center of astronomy in what's called the classical era. We're talking about, 500 AD, or sort of CE, Common Era, 500 to 1200 or something like this. India is on the cutting edge of astronomy. They're doing really impressive math, really impressive astronomy. They're doing it in places like, this is the Nalanda University, which I would really like to, again, come back and talk about later. The site seems to have been occupied from about 1200 BCE, but Nalanda as a center of learning gets going at about 500 CE and lasts until about 1200 CE. And this was really one of, if not the most important centers of learning in the world at the time. So we will come back to that, I promise. Okay, so now let's move on to Chinese astronomy. So when we're talking about China and ancient history, it's pretty ancient. So and China makes an interesting case study because the records are impressively continuous all the way back to like 2000 BCE. So like thousands and thousands of years of continuous record keeping about what was going on. China as a unified country doesn't really come into existence until the Qin era in 200 BCE or so. So please forgive the historical inaccuracy of talking about Chinese astronomy before that period, but I will go ahead and do that anyway because that's what everybody does. Okay, so here's an interesting astronomical observation that I think is a nice lead-in to the way that astronomy has political ramifications in ancient China. So the conjunction of the five pacers. So the five pacers are the planets. Now, planets, of course, move relative to the fixed stars. Now, in February 1953 BCE, so 19,000 or 1,953 years before the Common Era, something really weird happened in the sky. And this weird event was the five planets that are visible with the naked eye, as well as the sun and the moon, are also just before dawn. These five planets all appear kind of clustered together in the sky. They appear clustered together closer than they'd been for the last 5,000 years. So a really unusual event happens in the sky. And it also happened to be, if you look at the chart I just put here, the beginning, so 1953 BCE, is very close to the beginning of the Jia dynasty, the first sort of like Chinese dynasty that's clearly recorded. And this planetary alignment was interpreted by the rulers as a kind of heavenly ascent to the beginning of their rule. So they say, look, we just took over. This very unusual thing just happened in the sky. That's a good sign. And the same thing happens 2 or 3 more times. So there's another similar conjunction about 1500 BCE, and this conjunction is again regarded as heaven bestowing legitimacy on the rulers, on the change of rulership in this area. Now, this gets codified into a concept called the mandate of heaven. So, for a huge amount of Chinese history, astronomical events are interpreted as having political significance. And the mandate of heaven is the kind of the ascent of the natural world to the rulership, the rulership that's got power at that time. So, just like the ancient Mesopotamians did, ancient Chinese regarded events in the sky as having kind of political, both religious and political significance. This is Wang Yu, a fictional character, but he's got this sort of astronomical stuff, so I thought it made a good image. Okay, so by the Han Dynasty, back to this, the Han Dynasty is, where are we here? 200 BCE, so the Qin Dynasty doesn't last very long. The Han Dynasty lasts quite a bit longer. So by 200 BCE, the idea of the mandate of heaven had evolved into the notion that when the heavens behave regularly, that's a good sign. And when they behave irregularly, when unexpected things start to happen, that's a bad sign. So the more regular nature is behaving, the more the ruler has shown that they have the mandate of heaven. And if weird stuff starts happening in the sky, that's a sign that the ruler had better either step up their game or get out of the way for the next people. So, unlike the Mesopotamians, the Han Chinese did not assume that they already knew, in some sense, what the right model of the regular behavior of the heavens were. So, if you remember in the video about the Mesopotamians, we said they had this 360-day calendar, and to the degree that nature, with an intercalary month every 3 years, to the degree that nature followed along and met their model, they thought things were going okay. That model was pretty fixed. Now, in the ancient Chinese world, it was regarded as one of the responsibilities of a new emperor, or if you're starting a new dynasty, to fix up the calendar. So one of the ways that you establish your cultural legitimacy was to rectify the calendar, to create a calendar that everybody would switch over to and regulate their lives by. Things like market days and rituals and celebrations and that kind of thing and when taxes are collected, these are all regulated by the calendar. And when you are starting a new dynasty as an ancient Chinese emperor, what you're going to do is put in a new and better calendar. And that gives you an opportunity to redefine what it means for the heavens to be regular. Right? So regularity is a funny idea. Things are regular if they match your expectations. But if your job as the new emperor of a new dynasty is to change the expectations, that means you don't have a fixed target exactly. You're allowed to modify what you count as regular. So that puts an interesting incentive structure in this process, whereby the better you can make your calendar, the more sophisticated, the more accurate, the more true to nature you can make your calendar, the more stuff you get to count as regular, and therefore evidence that you got the mandate of heaven. So as opposed to the Mesopotamians, who had this kind of fixed target and nature either hit it or didn't, from the Han Chinese on, it was regarded as the normal thing to do was try to come up with a better model. So they had this series of better and better calendric systems, which make it easier and easier for them to say, yeah, this is what we expected to happen. So again, we'll just take a brief aside and talk about the information technology that's underwriting this. So when you're trying to build calendrics, when you're trying to build a better calendar, you need lots of data. You need lots of observations from long periods of time, probably over large geographic areas. How do you collect up this data? Well, one common technique was bamboo books. We got this collection of bamboo strips on which there's writing. This example is from like 300 BCE, so just before the Han Dynasty. The first emperor of the Qin Dynasty was reported to have read something like 25 kilograms worth of bamboo books per day. So that's a pretty weighty sort of, it's nothing compared to the clay tablets that the Mesopotamians were using, but this is still a pretty bulky information transmission medium. The very, very rich also would write things on silk, but as you can imagine, that's pretty pricey. Silk is not cheap, and so that's fairly limited in its use. Okay, so just to give you an idea of how information is being recorded and transmitted around this time. Okay, so back to calendrics. Before the Warring States period, which starts, so this is Warring States of China, 200 BCE or something like that, intercalary months were kind of added just as necessary, like it was in Mesopotamia, but during the Warring States period, they tried to come up with rules that would define when the extra month would be added. So the Sifēn, again, I apologize for my pronunciation, the quarter remainder calendar puts the solar year at it puts it at exactly 365 and 1/4 days. So that's pretty close to the actual solar year. And again, just like the Indians, the ancient Indians, ancient Chinese are using both a lunar and a solar calendar. There's a constant struggle to keep those things lined up. This is improved upon, for some senses of improved, by the Taichu Calendar. This was introduced by the first emperor of the Han Dynasty. This set the solar year at 365 and 385 over 1,539 days. So 365, and rather than 1/4, you have 385 over 1,539. This was actually a little less accurate than the quarter remainder calendar. But nonetheless, on the order of less than a day. So the quarter remainder calendar says 365 and 1/4 days. this says something like, I don't remember the exact figure, but it's like a fraction less accurate to the actual solar year. But the numbers involved were regarded as culturally significant. So the number 1,539 is a nice one. So that's the denominator of that fraction, is equal to 81 times 19. So 81 is 9 times 9. 9 is the largest heavenly number, so it's a propitious number. It's a good number to use. 9 times 9 is a nice number, and that's 81 times 19. And 19 is the number of cycles in the sort of adding in the rule of adding in intercalary months to keep the solar and lunar cycles added up. So again, we see a drive to accuracy driven by the mandate of heaven being tied to how regular the sky is. But that's not, again, we're way back in history here. Don't think of this as modern science where only accuracy is the important thing. The kind of symbolic significance of this stuff plays an important role as well. So here we see the symbolic significance, in some sense, slightly outweighing raw accuracy. Okay. In this period, again, calendrics is a big deal. It's going to continue to be a big deal throughout sort of medieval, early modern Chinese history. A number of astronomical tools are actually used. So this is quite an old one. This is called a Gnomon. Gnomon, I think this is from 300 BCE again, something like that. Well, this is a reconstruction, but it's basically like a sundial. So this is one of the ways that they measure things like the changing of the seasons and that stuff. So if you can see, this is a circular plate with a little spike sticking out of it. You stick this facing perfectly north-south under the noonday sun, and the position of the shadow that falls from that little spike will give you information about, so if you watch the way the shadow moves day after day after day, that'll give you information about the changing of the seasons and that sort of thing. Okay, so just very briefly, I think this is a fun and interesting example. Astronomical omens are not the only ones that are regarded as important for maintaining or monitoring your hold on the mandate of heaven. So if unexpected, large-scale natural phenomena happen, that can be worrying for you as emperor. So an earthquake is also regarded as a pretty serious issue. So if there's an earthquake that's very irregular, nature's not going through its normal sort of paces, so an earthquake can be a sign that something's gone wrong with your rule. In the late Han Dynasty, Zhang Heng, a famed mathematician and scientist, created one of these things. Now, this is a reconstruction. We don't actually have any of the originals left. What we have are descriptions of it. But it's something like a seismometer, something like that. So it measures movements of the Earth. Now, according to the description, and we have every reason to believe this is accurate, if there was an earthquake, you see the little dragon's heads around the top of the urn? They've all got little balls in their mouth. And if there's an earthquake, the ball falls out of the dragon's mouth into the frog's mouth, the little frogs around the bottom. And the description of how this actually works is a little unclear, but something like a pendulum on the inside. And apparently this actually worked. So there are believable historical records of earthquake happening some hundreds of kilometers away from the capital. And this thing, what it does is the direction of the dragon's head that drops the ball, because it's sort of like vibrating in that direction, is the direction in which the earthquake happened. Now at the time, one of these balls drops and they go, oh, maybe there was an earthquake. And everybody's like, yeah, I don't know, we're not sure. But days later, they get the report that there actually was an earthquake several hundred kilometers away. So as emperor, your speedy response to something like an earthquake is part of how you maintain the sense of your legitimacy with the heavens. So that's just, I just think that's an amazing and fun sort of example of the kind of technical ingenuity and skill that's available to people. This is late Han Dynasty. This is like 200 CE or something like that. So, yeah, so there's a kind of profound motivation generated not just from pure natural interest, but also by the image of how politics and the natural world and the spiritual world are all connected in this interesting web. So again, just like the Indians, just like the Mesopotamians, just like practically every ancient culture, what we have here is something like science, and it's tempting to just apply our notions of science to it, but with a very different flavor than the one that we're used to. Okay, that's it for today. Thanks.